Hello guys, today we're going to be doing the first 9 problems from the AMC 10B 2020. First problem, basic arithmetic. 1 minus negative 2 is 3, 3 minus 3 is 0, 0 minus negative 4 is 4, 4 minus 5 is negative 1, negative 1 minus negative 6 is 5. D. Cause 5 cubes, each having side length 1, Kate has 5 cubes, each having side length 2. What is the total volume of these cubes? Well, 5 cubed is, 5 times 2 cubed is 40, 5 times 1 cubed is 5, so the answer is 45, or E. The ratio of W to X is 4 to 3. Sorry about that, 1 second. Alright, and then y to z is 3 to 2. It tells us all this information. Z to x is 1 to 6. There's a ratio of w to y. We can try to cancel the variables, so I can have let's think about this. How do I want to cancel the x's, and then I want to cancel the y's? Cancel the z's, sorry. Oh, I think I've seen it. So w to 4 over 3, w over x times, then flip this 6 over 1, so I can eliminate the x's. X is gone, so think about it like this: w over x times x over z, and then we want to multiply that, and then we're going to flip the z to z over w. We're going to get w over x. So all these cancels, and that. Z over w would therefore be 2 over 3. Let me get our answer. So 48 over 9 simplifies to 16 over 3. So the answer is going to be E here. Next problem, can change the color to red, I guess. The acute angles of a right triangle are A degrees, B degrees, where A is greater than B, and both A and B are prime numbers. What is the least possible by B? So basically, you have to find the highest prime number less than 90 degrees, and I subtract that from 90 degrees to find the answer. So basically, let's see, it's 87, less times 15, so it's not prime. How about 85? Obviously, it's not prime because it's divisible by 5. 83, I think it is. Let's see. Well, 83 is not divisible by 11, it's not divisible by 13, 17, I don't think. I'm just going to go with this. I'm going to use my instincts. And I'm going to say the answer is going to be 7 degrees, or D. How many distinguishable arrangements are there from 1 brown tile, 1 purple tile, 2 green tiles, 3 yellow tiles, in a row from left to right? The tiles of the same color are indistinguishable. So we don't really care about the same color. What does this remind you guys of? Word rearrangements, guys. This is literally the same exact thing. It becomes so simple. We start with the number of tiles of 1 plus 2. 1, 2 plus 2 plus 3 is the same thing as 7. Put factorial sign, and then we divide by the number of duplicates. We don't 1 don't duplicate. 2 and 3 do, so we divide by that number of factorial. So this is the formula. And if we cancel the 3's and 3's, we're going to get 840. Sorry, we're going to divide by 2 factorial. We're going to get 410, right? And 420. I'm tripping today. Okay, the answer is B. Driving along a highway, Megan was at her dominant showed 15951. This number is a palindrome, reads the same forward and backward, and 2 hours later, the hard mistake. The next higher palindrome. This higher palindrome, let's think about this. It has the form A, B, C, B, A. A, B, C, B, A. A, B, C, B, A. Let's think about this. We don't have any numbers in the same quadrant here. We have to go up to 1, 6. So 1, 6, maybe 0 will be to make this small, and 6, 1. I assume this is this y run. These two have a difference, let's see, of 110, and we divide that by 2, we get 55, because it's the average speed in 2-hour period, so it's BP. How many possible even multiples of 3 less than 20 are perfect squares? Even means that also multiples of 3, so multiples of 2 times 3, or 6, so multiples of 6, perfect squares. So that's important. We know that the highest perfect square, multiple of 6, would be 42 squared, as this is going to approximate to some number. But 48 squared is going to be some number 2, 3, I don't remember the rest, but I think something like this. So I think that's how you approach this. And if 42 is the largest, and if you do 42 divided by 6, because it's multiple 6 and 7, you're going to get A. Points P and Q line of length PQ equals 8. PQ 8, and then multiplication point R. PQ and R is a right triangle every 12 units, means the height equals 3. So we can have this. This is always be 1, 1. So I think we're going to duplicate on each side. 1, 1. We can have one where R is the vertices with the right angles. Right? Same thing with this one. And then you can have another one, something like this. Also right, where this is also right? This idea. And so I basically have 2 for each. That's just the idea here. And that's just 2 times 4, 8. So it's going to be 8. D, sorry. How many ordered pairs of integers satisfy the equation? Well, x, we're going to minimize x. X could be like 0. Y could be 0. Like x could be 1. Y could be 1, I think, right? Because then, yep, that's true. I think. X could be -1. So then -1 squared. And then y could be 1. I'm missing 1. It's got to be something. Let's think about this. Or if y was negative, y could also be, y could be -1, x could be 1, I think. 1 squared, yeah. Wait, it won't work. Sorry. Let's see, x could be negative, well, oh, we can have 0 and then, 2, right? 0, 1, well, 4, I think, right? 1 squared, so it'd be 0 plus 2 squared is 4, 2 squared is 1, 1, 2, 0 and then 4 times 2. Yeah, so there's going to be 4 solutions. I mean D. And that's it. The first 9 questions is done.